Okay, so this is a demo for our project. Um, so Andrew, can you run MiniNet and then Ryu? Is a radio side controller? No. Is a MiniNet topology? We have two different switches with four different hosts. So host one, two, three will have IP assigned time point 0.0.x belong to switch one, and then host four with IP of 11.0.0.10 belong to switch two.
All right, and then we go ahead and do a ping all command so that all the hosts in the first subnet can learn one another's MAC address and therefore build steady connections between them. And when we do this, the controller also assigns a VIP, that's a virtual IP, to each one of the hosts that it will now be using between communication of the hosts. Um, yeah, as we can see here, each one got a virtual IP assigned, and this starts a 30-second cycle, where in each cycle, a new virtual IP is assigned, as we can see there on the bottom. Right, host 10.0.0.1 got assigned 10.200 all the way to 72. Same for host 2, ending in 248, and 3 ending in 45. And then we can go ahead and add the attacker to the first subnet through the following command. And we add this command because we want host 4 to be able to reach the first subnet through the switch 2 to switch 1, essentially creating a bridge. And we do this because we're just simulating the functionality of the MTD algorithm. Um, yeah, so we can go ahead and do a nmap scan from host 4. And I'll let Andrew explain the rest.
Yeah, so we'll begin with a Nmap scan of the virtual IP network. So if we go ahead and do that, um, while we're waiting, I'll go ahead and explain it a bit. So pretty much right now we're going to be scanning the virtual IP network, and the expected result that we should see here is that we should see a couple of the hosts up. Um, at most, we will see three. So right now we see three hosts, but there is potential that if we do get caught in the middle of the mutation, that the nmap or that the scan of the network can return less than three hosts up. But we do see that we can see the three hosts up on the virtual IP network. And then if we do the same thing, but we do it on the real IP network or using the real IPs, we should expect to see none of the hosts up because we are protecting the host behind virtual IPs. So an external attacker, in this case host 4, shouldn't be able to see their real IPs to be able to potentially send a malicious attack in the future. And as we can see, there are 0 hosts up. And then to show connectivity within the network itself, we can go ahead and run pings between hosts themselves. So here we're going to have host 1 ping host 3, and we should see all 3 packets get through from host 1 to host 3, and we do see all 3 packets have been received. Then if we do the same thing, but we go ahead and ping the real IP of host 3, so .0.0.3, we should also see all 3 packets get through. But if we go ahead and do the same thing, but we try to ping the virtual IP of host 3, this should not get through because that is not supported in our MTD. Our MTD is going to intercept packets and then go ahead and reassign the real IP that you're trying to get to the VIP, and it does not actually spin up or add a host at the connection. So here we see that host 3 is at 198 now. So let's do a ping of 198, and we can see it is unreachable. And this demonstrates that our network is functioning properly internally and is properly hiding the hosts from external scanning.